Feature selection. Feature selection is about selecting meaningful variables. Here we'll begin with a remark on overfeeding. If a model performs much better on a training data set than on the test data set, then it is a strong indicator of overfeeding. Overfeeding means the model fits the parameters too closely during the training step, but the trained model does not generalize well to new data. The reason for the overfitting is that our model is too complex for the given training data. There are common solutions to reduce the generalization error. That means that to enhance the generalization accuracy. Okay, here we have 4 solutions. Collection of more training data, but it is often not applicable. At the moment of given data, we have to train the model with the given data so that collecting more training data is not easy. And also, each data point requires money in data acquisition. Introduce regularization, and along with a penalty term, the complexity may be reduced. Choose a simpler model. Okay, choose a fewer parameters, and that is a solution. And the final solution is reduce the dimensionality through feature selection. And so here, feature selection is now selecting the variables, features meaningfully. Feature selection, also known as variable selection, its objective is fourfold: enhancing generalization by reducing overfitting, providing faster and more cost-effective predictors, reducing training time, and providing a better understanding of the underlying process of data acquisition. Here we have recall for curse of dimensionality. The curse of dimensionality describes the phenomenon where the feature space becomes increasingly sparse for an increasing number of dimensions of a fixed size training data set. But when we select the features so that the dimension is reduced, then the phenomenon on curse of dimensionality will be reduced. Okay. Here we have methods for automatic feature selection. The first category is filter methods. Filter methods suppress the least interesting features after assigning a score to each feature and make ranks of the features. And the method considers the feature independently, which means that consider features one by one, and least interesting feature must be eliminated based on the scoring measure. Wrapper methods evaluate subset of features to detect the possible interactions between features. So these methods prepare various combinations of features and compare with other combinations. So it can be quite advantageous. However, those methods have 2 main disadvantages. Increasing overfitting risk when the data size is not big enough. Also, here significant computation time for large number of variables, because large number of variables will make a huge number of combinations. Now, third category is embedded methods. These try to combine the advantages of both previous methods. So try to combine advantages from filter method and wrapper method. Here, the most common type of embedded feature selection methods are regularization methods, and such as Ritchie regression and lasso. Lasso is now error-norm regularization technique. Here we'll see how error regularization can reduce overfeeding, so that this technique can serve as a feature selection method. Here, let's see a filter method, sequential backward selection. The idea behind SBS algorithm is quite simple. And the method sequentially removes features one by one until the new feature subspace contains the desired number of features. In order to do that, here some criterion function must be used. And for example, performance of the classifier after the removal of a particular feature, so that, for instance, accuracy measure can be used for criterion function. Then, now here, the feature, we have to select, remove the feature that maximizes this criterion. That means that we try to eliminate a feature that causes the least performance loss after removal. Look at here the algorithm. Now we start with case D, the dimensionality of the full feature space, and we will determine a particular feature along with that measure, maximizing the accuracy when each feature is subtracted, so that if there are now k feature columns, then first we eliminate the first column and try to get now accuracy, and now again for second column we eliminate it and try to get the accuracy after training, and so on. So for each column, after elimination, we try to train and then measure the accuracy. Among them, we are choosing largest feature column, that is now every hat. Now that every hat will be eliminated, and then we'll go again in next iteration. Here, along with this operation, now the maximum means that once feature column is eliminated, then possibly the accuracy will be lowered. But for some typical feature, the accuracy is less reduced. That means that the feature, the column, is not so important. So that least important feature will be eliminated and keep going this operation. So that is called the sequential backward selection. That is a kind of filter method. Okay, we'll continue in the second part. Thank you.